So in previous lecture, we have seen that we know that what is the equation for capacitance in terms of Maxwell coefficient. It is nothing but 1 upon 2 pi epsilon 0 in matrix form. As I told you, we know that the formula of charges in terms of Maxwell coefficient, it is, and you know that this P inverse is nothing but M into Phi. Okay, where this Q matrix, it can be defined as Q1, Q2 up to Qn, that is suppose n by 1. Then this Phi, there is a voltage matrix, it is P1, P2, P3 up to Vm. It is also n by 1, and it is M, it is nothing but M11, M12 up to M1n. Likewise, M21, sorry, M21, 31 up to Mn1. Same way here it is Mn into n. Here this M is nothing but, you know, that it is P inverse, and that P, that is Maxwell potential coefficient, it is ln of 2hi upon R equivalent. So whenever we are talking about 2hi, this is Pii, right? Self, or we can say it is Pjj, P11, P22, P33. So in this case, Pii or Pjj is equal to ln of 2hi upon R equivalent. When to consider R equivalent? In case of bundle conductor. If it is if it is a single conductor, then it is only R. Now this is what self coefficient, and if I'm going to find out the mutual potential coefficient, P of ij, it is equal to ln of I of ij upon A of ij, where I should not be equal to j. हे आठवत असेल तुम्हाला. We have considered these conductors above the ground. Okay, this adjacent distance is I of 1, 2. Similarly, this is I of 2, 3. Same way, this is I of 3, 1. This distance of separation, it is A1 to A2, 3. Similarly, from 1 and 2, sorry, 1 and 3, it is A1, 3. So in this case, how to find out P of 1, 3? It will be ln of I of 1, 3 upon A of 1, 3. And if I'm going to find out P of 1, 1, so it will be ln of 2h1 upon R equivalent. If these all the distances are same, means all the conductors are of at a same height, means either h1, h2 and h3 all are equal, then it will be 2h upon R equivalent. If these distances or heights are different, then for P11 it is 2h1 upon R equivalent, then P22 cancel ln of 2h2 upon R equivalent, and similarly P33, see, P22 it will be ln of 2h2 upon R equivalent, and I will consider that this all the conductors are having radius small r, so this will be R equivalent, and similarly P33 will be ln of 2h3 upon R equivalent. Same way, what will be the P23? P23 will be ln of I23 upon A23. So in this manner, we can calculate that matrix M, or P of ij, or I of P of ii. Okay, so if you remember these all the derivations and the factors, how we derive this, we will move further for that derivation, that is calculation of electrostatic field of a single circuit of a three-phase line. Here, what we are going to do, let us say suppose this is one conductor, it is above the ground, and its image below the ground. Both of them are having same radius. Now, here we are going to consider origin O, and generally this origin is considered on the ground. Okay, So I will consider this is origin O, because we have to consider x and y axis. So let us suppose this y axis, this is x axis, and this conductor, it is at a height, let us say suppose yi. This height is yi, and this distance, it is xi. ज्या कंडक्टरचा जर आपण कोऑर्डिनेट्स फाइंड आउट करायचे असेल विथ रिस्पेक्ट टू ओरिजिन ओ, then it will be yes xi into sorry xi yi. ओके, सो सिमिलरली याचं काय असेल xi मायनस yi. या कंडक्टरचे जे काही ओरिजिन असेल ते xi आणि मायनस yi असेल. फाइन, we'll consider a point A in the space which is having coordinates x and y, and at this point we have to find out the electrostatic field. Okay, so see, as this point it is in air, the electrostatic field at this point it is due to this conductor as well as this conductor. Okay, suppose this conductor is carrying charges qi, so image of this conductor will carry a charges of minus qi. बरोबर है ना? Okay, so as I told you, this point A, it is having coordinates x and y. It means what? This distance is, anyone please, what is this distance? या पॉइंटचे कोऑर्डिनेट्स जर x आणि y असतील तर ही हाईट काय असेल?
Y.
y. Very nice. And this distance will be
X.
x. Good. Now, as I told you, this conductor is carrying charges qi and its image is carrying charges minus qi. The electrostatic field present over here, it will be due to qi as well as minus qi. So I will consider the distance between these 2 points from the positive charges, it is di, and the field due to this qi will be in the direction of this, and this field is considered as EC. Okay, so EC is nothing but the electrostatic field due to positive charges qi, and for simplicity we are going to divide this field, means how field vector जो आहे EC, it is in horizontal and vertical component. See here, this is point EC, and या EC ला जर मी horizontal आणि vertical component मध्ये जर divide केलं, so this will be, let us suppose this angle is, मैं आता या केस मध्ये आपण काय केलेला, हा कंडक्टर कन्सिडर केला, आणि इथे जर हा अँगल जर थीटा असेल, बरोबर आहे, so this angle is also theta. As this is EC, I will consider it is as a horizontal component EH, and this will be vertical component EV. So let us suppose the charge, sorry, electrostatic field at this point A, due to these positive charges QI, it is ECI. This ECI is divided into two components, one is a horizontal and one is a vertical. So the horizontal component is EHI and vertical is EVI. This can also be drawn as, म्हणजे हे जर horizontal and vertical असतील, you know that the phasor sum of these two is nothing but ECI. So हीच फिगर आपण अशी ड्रॉ करू शकतो का? This is what EHI plus EVI, it gives ECI, where this angle is theta. Okay, so here based on this concept, as I told you, the electrostatic field at this point, it is divided into two components. One is a horizontal, which is called as a EHI, and another is a vertical component, which is EVI, as this angle is theta. Similarly, this is also theta. Now, आता ही जी ECI field आहे, it is due to positive charges, right? Again, at this point A, there is another field due to negative charges if we uh, neglect the field due to positive charges. So let us say suppose आता या केसमध्ये दिस फील्ड इज आउटसाइड फ्रॉम दिस, म्हणजे हे जे डिस्टन्स आहे त्याच्या नॉर्मल असतं, नॉर्मलला आउटसाइड असणार आहे. बट द चार्ज ऑन दिस कंडक्टर इज निगेटिव्ह, दिस फील्ड विल बी इन दिस डिरेक्शन. जर पॉझिटिव्ह असतं तर ती या डिरेक्शन मध्ये असते, बट ॲज इट इज निगेटिव्ह द फील्ड ड्यू टू दिस इज इन दिस डिरेक्शन. ओके, आणि ती जी फील्ड आहे तिला आपण कन्सिडर करूयात ECI डॅश. ओके, परत ही फील्ड मी काय केली, I have divided into two components. One is a vertical and another is a horizontal. So this is vertical component and it will be E phi I dash. And this is horizontal component. It is E H I dash. And this is total. I will write it down again. ECI dash. This angle is also theta. We have considered a conductor which is having radius r and its image below the ground. Now, as I told you, we have to calculate the electrostatic field at a point, let us say suppose this is point A, due to these two conductors. And to solve this derivation, we have considered a origin O, which is on the ground plane, having coordinates, means origin at point O. Okay, so this is x-axis, and this one is y-axis. This conductor, त्याची जी height आहे ही आहे yi. Okay, असं म्हणूयात की जी height आहे या कंडक्टरची from x-axis it is yi, and this distance of this conductor from origin, it is equal to xi. Any doubt? Now, as I told you, we have to calculate the electrostatic field at point A, which is at a distance or at coordinates, which is having coordinates x and y. This means what? This height is y and this distance is x. Means from x-axis, the height of this point A is y, and from y-axis, its distance is x. Now, there is an electrostatic field present over there at point A due to charges Q, that is positive charges Q, and Q negative charges Qi. As an overhead conductor आहे above the ground, it is carrying charges Qi, but its image, it is having opposite charges that is minus Qi. And at point A, the field exerted, it is due to these two charges. Now, due to positive charges, the field will be in outward direction, and it is called as a ECI. Okay, and for simplicity, let us say suppose this angle is theta, so this angle will also be theta, and we are going to divide this ECI into two components. One is a horizontal and one is a vertical. So let us say suppose this is horizontal component, it is EHI, and this one is vertical component E phi I. And you know that this EC is nothing but phasor sum of EHI and EVI. Okay. Now, as I told you, at point A, there is a field due to the negative charges also. So I will draw the line along this line. Straight line आहे, इमॅजिन करा. आता हे चार्जेस निगेटिव्ह असल्यामुळे आता इथं हे पॉझिटिव्ह चार्जेस होते म्हणून ही जी इलेक्ट्रोस्टॅटिक फील्ड होती ती अवे फ्रॉम चार्ज होती, राईट. इथे निगेटिव्ह चार्जेस आहे त्यामुळे ती फील्ड जी असेल ती इट विल बी टुवर्ड्स दिस डिरेक्शन. सो लेट अस सपोज दिस इज ECI डॅश. निगेटिव्ह चार्जेसमुळे आहे म्हणून त्याला ECI डॅश म्हटलं मी. परत मी हे काय करणार आहे, आय एम गोइंग टू डिवाइड इट इंटू टू कॉम्पोनंट्स. One is a vertical, and that vertical is nothing but E phi dash, and another is a horizontal E h I dash. Okay, this distance means distance of point A from QI, it is di. Okay, so if I consider this triangle, I will extend this toward this. इथपर्यंत डिस्टन्स काय आहे या पॉईंटचं? हे डिस्टन्स किती आहे? Yes, anyone? What is the distance between these 2 points from this? It is equal to xi. Am I right? Yes or no?
Yes.
Okay. What is this distance total from this point to this point? या दोन पॉइंट मधला डिस्टन्स किती आहे?
X.
X. So what is this distance?
X minus xi.
Xi. Very nice. So see, this distance is x minus xi. Same way, if we consider this point to this distance is y. Okay. Now, if I consider this point, this distance is yi. So what will be this? Y minus y. Am I right? बरोबर आहे का?
Oh.
Okay. So if I consider this triangle, I will redraw it, in which this is di, this is x minus xi, and this is y minus yi. Di will be under root x minus xi square plus y minus yi square. Is it okay? फिर समझते का? Yes or no? Hello everyone. Good. Now I will extend this distance, this also. Okay. Here distance किती है? X minus xi. Now this distance will be, anyone? Can you tell me? या हा कंडक्टर म्हणजे काय? या कंडक्टरची इमेज आहे, बरोबर आहे? या ग्राउंड लेवल पासून या कंडक्टरची हाईट किती आहे? y आहे. सो ग्राउंड पासून खाली याची हाईट किती असेल? इट विल बी y आहे, राइट? Yes or no?
Oh.
Okay. So let us suppose this distance is yi. From this point, what is the distance? Means या ग्राउंड पासून a पॉइंटचं डिस्टन्स किती आहे?
Y.
Y. So this total distance will be
Y plus yi.
very nice. Y plus yi. Okay. So in this case, let us suppose the distance of point A from negatively charged, it is di dash. So if we consider this triangle, this height is y plus yi, this is x minus xi, and this is di dash. So what is di dash? Under root, according to Pythagoras theorem, it is x minus xi square plus y plus yi square.